And in today's episode, among other things, you'll see that in different parts of the world, we already have robots working on their own. Also, drones delivering products in minutes, and mechanical hands that are learning to feel touch, almost like us, human beings. And also energy starting to be extracted straight from the heart of the Earth. And when we put all these pieces together, we realize that the future has already arrived and will impact your daily life and mine much sooner than we imagined. Let's understand all of this. Hello, impressed viewers. I'm Carlos Alves, and you're watching Amazing Reality. Historically, robots have only performed specific commands and isolated tasks, but now they are starting to make decisions on their own, based on what they are seeing, hearing, and, in quotes, feeling. Boston Dynamics has just released Update 5.1 for Spot, its quadruped robot. In addition, there's also a new version of Orbit, the software that manages fleets and analyzes data. The goal of this update, of course, is to speed up real-world deployments at scale with new workflows, corporate control, and a completely renewed set of sensors. This change centers on closer integration between the physical robot and cloud-based AI models. According to the company, both Spot and Orbit were designed to continuously learn about the facilities where they operate. With this power, improvement happens over time without constant reprogramming. In practice, this means the robot goes from being just a data collector to acting continuously as a live inspection system. The biggest leap of this update is in the new Spot Cam 2. It has a 4K pan-tilt zoom camera with 25x optical zoom, a built-in radiometric thermal camera, 360-degree panoramic view, and supports acoustic imagers that detect leaks, vibrations, and mechanical failures by sound. Spot now combines image, heat, audio, and video in one multimodal inspection, all focused on the same spot. This allows you to identify problems invisible to the human eye before they become critical failures. And more. The robot can now open doors by itself, without any extension. In test with beta customers, Spot has already opened more than 2,500 doors automatically, thus navigating through areas that were previously inaccessible to it. With this, Spot evolves from just an inspection robot to playing a broader role in the facilities. Update 5.1 adds autonomous security patrols that can identify people, record images, generate alerts, and decide to continue, pause, or end missions. Robots like Spot already patrol, inspect, and make decisions on their own, inside factories and critical facilities. But when autonomy moves from the ground to the sky, the scale changes entirely, all right? For decades, delivery has always been the slowest link in technology. Products advanced, platforms evolved, but the package still depended on traffic, stoplights, and human drivers. Now that bottleneck is fading, not with promises, but with actual results. Zipline has just surpassed the milestone of 2 billion commercial deliveries made by its drones. It also raised over $600 million in funding, boosting its market value to $7.6 billion. The announcement coincides with the company's expansion into Houston and Phoenix, with more major metro areas to follow this year. Zipline delivers food, retail goods, and health items to customers' homes in minutes. Using its fully autonomous aircraft, the system basically works as on-demand aerial logistics. The customer places the order through the app. The drone automatically takes off, flies for about 3 minutes, and precisely drops the package at the destination. All this occurs without traffic, emissions, or human contact. The numbers show this is no longer an experiment. Zipline's United States deliveries have increased about 15% each week. In the last 7 months, their aircraft have flown more than 200 million kilometers in autonomous commercial flights, delivering over 20 million items, and all of this without recording any serious accidents. The adoption curve is most impressive. The company's first unit took 10 weeks to achieve 100 daily deliveries, but the latest units reached that in just 2 days. This marks a key turning point. Drone delivery is becoming basic infrastructure like today's mobile internet or global positioning system. Other companies are doing the same. Walmart and Wing plan over 270 drone delivery points by 2027, linking cities from Los Angeles to Miami. Now consider this with me. If drones can already deliver food, medicine, and supplies in just a few minutes without any pilot or human driving, then why do we still need to drive our own cars? Robotaxis were once seen as a distant promise. Some prototypes used to run on closed circuits with limited, restricted tests, but now things have changed. Three major companies, Lucid Group, Neuro, and Uber, showed maturity by unveiling a Robotaxi prototype set for release in 2026. The vehicle is based on the Lucid Gravity, a fully electric SUV. But what really sets it apart isn't just the design or the comfort, it's the brain of the machine. The driving is controlled by Neuro's Level 4 autonomy, which means the vehicle can operate on its own in defined urban environments. And all of this happens without any constant human intervention. And most importantly, public road tests have already started since December, with safety operators only supervising the system. This changes everything. We're not discussing simulations or demos anymore, but validation in real traffic with pedestrians, cyclists, unpredictable intersections, and city chaos. The Robotaxi features 360-degree vision with high-res cameras, radars, and solid-state LiDAR built into its body, plus a spectrum halo on the roof. Everything was carefully designed to preserve the vehicle's appearance. External LEDs help passengers identify the correct car by displaying initials and showing ride status inside. Uber designed the experience with a clear focus on transparency. Passengers don't just enter the car, they understand what it's doing. Screens show in real time what the Robotaxi sees, how it interprets the environment, and why it makes each decision. Stopping at a light, yielding to pedestrians, changing lanes, or selecting a drop-off spot, all are shown on screens, and this isn't just for looks. It has a psychological effect. Trust in autonomous vehicles comes not from hidden perfection, but from understanding the process. The Robotaxi's no longer trying to prove that it works. It's trying to prove that it's trustworthy, and I don't know if you know. But autonomous vehicles, sensors, data centers, and AI all working in real time together, they have something in common: massive energy consumption. And this is exactly where technology comes in. Almost invisible, but absolutely decisive. The energy we need has always been available beneath the Earth. Now, for the first time, a company claims to have found a safe way to turn the inside of our planet into a giant battery, capable of storing and releasing clean energy. On demand. 6Gel Systems has raised $97 million in a Series B round to build the world's first commercial pressurized geothermal plant in the United States. The ambitious project aims to overcome the historical limits of geothermal energy. For years, geothermal energy was considered an interesting but limited solution. It depends on very specific locations, high water consumption, and very high initial costs. It works well, yes it does, but only where the geology helps. 6G aims to change everything. Instead of relying on natural reservoirs of steam or hot water, the company bets on hot, dry rock formations, which are much more abundant beneath the Earth's crust. The secret lies in using not only the heat, but also the Earth's natural pressure. The system works like this. Water is injected deep into controlled fractures in the rock called pulmonary fractures. They expand and contract elastically, like underground lungs, storing hot water under high pressure. The energy remains stored until the system releases the pressurized water, turning its heat and pressure into electricity. The company reports up to 50% greater efficiency than traditional geothermal systems. In practice, it's not just generation, it's geothermal energy storage. It's firm, clean, and continuous energy without depending on sun or wind, stable energy 24 hours a day. This aims to support AI infrastructure, data centers, autonomous fleets, and smart cities. When this infrastructure appears on the streets, it gains a body, movement, and physical presence instead of being invisible. In Guangzhou, in southern China, passengers cross the corridors of Wangshengwei Station while being watched by something that, until recently, belonged to science fiction. The GoMate Mini, Guangzhou Automobile Group Motors Mini Metamorphic Humanoid, was there. It wasn't there to entertain, but to watch, guide, and respond. At first glance, the GoMate Mini looks like just another service robot, but as soon as you see it move, you realize there's something different about it. Its structure combines wheels and variable legs, allowing it to switch between modes of locomotion as the environment changes. In long, clear corridors, it lifts onto two wheels, rises to 1.75 meters, and speeds through tunnels at 4.2 meters per second. It's faster than an intense human sprint. In a crowd, it lowers its center of gravity, shifts to four-wheel mode, and stabilizes to safely move among people in real time. With 27 degrees of freedom and a 20-kilogram load capacity, it's more than agile. It's functional, able to assist passengers, transport equipment, and integrate with the urban environment. What truly makes the GoMate Mini unique isn't its mobility, but its timing. Guangzhou Automobile Group built the robot to serve as a rapid response agent in emergencies. It completes the full protocol in under 10 seconds, alerts authorities, precisely locates the site, and starts live video to the command center. All of this is supported by computer vision, autonomous navigation, intelligent obstacle avoidance, and even immersive teleoperation, where a human operator can literally see through the robot's eyes using virtual reality. And yes, it's continuous surveillance without fatigue. And the autonomy isn't just cognitive, it's also energetic. Many robots struggle with short shifts, but the GoMate Mini runs for up to 8 hours and doesn't need help when its battery is low. It goes to a charging station, recharges in an hour, then resumes work. In critical operations, it supports hot swapping the battery, reducing downtime to just a few seconds. In practice, this means an almost uninterrupted robotic presence in public spaces. And the subway is just the beginning. Airports, terminals, and busy urban areas are next. And the GoMate Mini doesn't just represent a robot patrolling a station, it symbolizes something bigger: the normalization of humanoid robots in everyday Chinese life. But beneath this seeming autonomy, for now, something essential and deeply human remains. Real hands, teaching the machines to touch, feel, and even act with great precision. It's not a lack of intelligence that still makes humanoid robots clumsy. It's a lack of sensitivity. For years, we taught machines to copy the movement of human hands, but we never allowed them to actually feel the world they were touching. A Dutch company has just tackled this blind spot. Manus has introduced the MetaGloves Proaptic, professional gloves intended not for gaming or virtual reality, but for advanced uses like humanoid teleoperation and embedded AI, the kind that needs to learn physically, not just from data. The system relies on a little-known technology often found outside industry: electromagnetic field tracking. Unlike cameras that capture data when there's occlusion, or inertial sensors that accumulate error over time, this method creates a local field and measures every millimeter-level micro-variation from finger movements. The result is a digital twin of the human hand with 25 degrees of freedom, capturing finger positions, rotation, orientation, and metacarpal movements. Exactly the kind of data neural networks need to learn fine manipulation in the real world. But capturing movement is not enough. The biggest problem in modern teleoperation is something researchers call the numb hand. The operator sees the robot touch an object, but feels absolutely nothing. Lacking tactile feedback, the brain uses unrealistic force, squeezing too hard and passing through virtual objects, producing impossible data. This is the bottleneck that the Proaptic MetaGloves are trying to solve. By integrating haptic feedback, the gloves give the operator back the sensation of contact, resistance, and also pressure. Subtle vibrations signal the precise moment of touch, helping the brain adjust force and complete the sensory motor cycle. Interestingly, the launch is happening amid name confusion. Although there is a Manus II connected to the world of artificial intelligence agents and recently acquired by Meta, the Dutch Manus remains independent, focused only on the physical layer of robotics. Once humans transfer strength, precision, and sensitivity to robots, software is no longer the limit. The next step is the technology itself, learning to adapt to our world. Human hands have always been regarded as the pinnacle of biological dexterity. The thumb is quite important, but the truth is less comfortable. Try reaching under furniture and you'll see your body twists, your wrist strains, and a simple task turns into a mechanical problem. It was exactly this limitation that researchers at École Polytechnique Fédérale de Lausanne in Switzerland decided to challenge. Instead of copying the human hand, they did something more radical. They set out to surpass it. Aude Billard's team created a reversible, modular robotic hand that can use up to 6 identical fingers. There is no special thumb or finger hierarchy. Any finger can act in opposition, like our thumb, allowing for stable grips in various ways. This hand doesn't just rely on an arm, it detaches and crawls when needed. Look, there's the Ada's family. The robotic hand acts like a mechanical spider, moving independently, navigating obstacles, and grabbing objects out of reach for traditional robotic arms. It can move objects while in motion, a process researchers call locomotive manipulation, which changes everything. The hand can hold objects with its palm, the back, or both sides, and it can carry several items at the same time while moving. With 5 fingers, it can mimic nearly all human grips that use more fingers. It can even perform tasks that usually need 2 human hands, using just one robotic unit. The applications are simple. Robots and humans can use them as prosthetics. While this hand isn't anthropomorphic, researchers note the human brain is highly adaptable. Previous studies show people can incorporate extra robotic fingers into their body schema, meaning abilities beyond the human body are possible. They can be learned among working robots, systems that learn much cleaner energy, and machines that expand what we are capable of doing. Technology is beginning to play a much more mature role in solving real problems. The future doesn't have to be cold or distant, much less bleak. It can indeed be more efficient, more humane, and better than the present. I assure you, if we know how to use it well, of course, right? When I say I assure you, that's why. Remember that all the sources for everything you've seen are here in the description. Thank you very much for sticking with me until now, and I'll see you in the next one. Just click on one of the 2 suggestions on your screen. I'll be waiting for you there, all right? Thanks, bye-bye. That's it, guys.